Let's get started. Yeah, so my name is Jeff, also program on the internet. This is a demo of Manifold, which is very early. Like most of this was put together like a week before submission. And given time, I'm mostly showing. I'm not talking about it or explaining it. So talk to me afterwards to get an explanation and give me feedback. It's really important. Nobody's really seen this. So Manifold is a system for interactively assembling software components, eventually in a mostly language-independent way, but for now, just Go. How many Go people in here? Any? All right, fine. There's also a JavaScript implementation, but the goal is to make building and interacting with software closer to working with a design tool, but in a bottom-up way, so you're building on top of the language as opposed to building like a top-down Adobe product. And besides being very early, Manifold is not like a complete solution. It's a primitive, so you could use it as a kernel for malleable software, or as a foundation for live programming environments, or I've been thinking of it as maybe doing a new kind of shell. You could say all of this stuff about Smalltalk, but this is sort of in a way that works with the world, maybe. Inspiration, obviously, we've got stuff. The middle row are a bunch of software design tools that I like. Visual Basic, Flash, Unity is a big one. Huge, really the main inspiration for a big part of this. But also like Unix, Bell Labs back in the days, thinking about these abstractions of file systems and the shell, right? They invented these like ideas, these abstractions that they also refined in Plan 9. I'm sure many of you are Plan 9 familiar. And then I don't know how many of you know this, but a lot of that deep Unix philosophy worldview was sort of embedded in Go because it was all the same, authors of Plan 9. Go is also people call it a very productive language, especially for a systems language, which is very interesting. So let's see an example. We'll build an HTTP server. You're all familiar with HTTP servers, right? I mean, we'll build it in Go first, and this is very simple since Go has a great standard library with an HTTP server in it. But just to kind of walk you through, basically we're assembling 3 components. We do one, which is a net listener, which lets us accept sockets. I'm not sure how many. Anyway, I like the net listener abstraction. Another component where we're basically putting together the handler, the custom logic for the HTTP server, in which we will just return hello world. And then, of course, we'll have the, okay, where is my scrubber? We're playing video. There it is. Okay, good. So we built a server, and then we activate it, and we run it, and we get a hello world. Yeah. This is to orient non-Go people too. Let's build the same thing, but in Manifold. But I have to reorient you now because there's this UI on the left. The program on the right is actually running right now. This is a live environment. And really all it's doing is exposing this sort of direct manipulation API that this extension, this VS Code extension, is giving us a user interface to. So this UI is not specific to Manifold, but we'll be using this and see. We'll just add some components, so add the TCP listener, add the web server. Let's see, configure it. Our component, we can just sort of generate stub 4 and then fill it out. We'll do the same thing, return hello world, and then we'll activate the system by hitting this little play button. Even though it's running, we're activating what we wrote. We get hello world. That took like half as long as it took to write Go code, but that's not really the point. The point is that this is a live environment, so everything's faster, exploration, iteration. We could go to this handler that we put together and changes, put a message field on it and then have it return the value of that. How are we going to set that message field? Well, we've got this cool inspector. We can just set that string there and hit play, and we go and get hello message. And of course, this is live, so. But we can also start doing other stuff like adding new fields to this struct of different types and hitting save, and then our inspector updates in real time, and we can add methods, and we can mess with this data, and then we can call the method that we added dynamically. So it's like we turned Go into almost like a dynamic language through this API. We basically made Go into an interactive live programming environment, which is interesting because most of the time you see these implemented in JavaScript or Lisp or Smalltalk or whatever. So to have this language that is out there that is used in the industry all over the place is pretty interesting. There's sort of three ideas, three legs to this manifold thing. One is this component programming model, which is really just how I write. Well, first it defines what a component is. So it's just it's a type with fields and methods, which struct satisfy. So any object-oriented object will satisfy what a component is. We just call them components in this model. We also, again, just like Go best practices, we lean into interfaces, which Go has a great great implementation of. I don't have time to get into all of this, but if we do this, then we can do some cool dependency injection stuff where we automatically wire things up. The other big part of Manifold is the direct manipulation runtime, which is both that hot reloading, so you make changes and updates without having to restart anything or get in the user's way. But mostly it's this reflection API. And Go, part of what makes this possible for systems language is Go has a reflection API. It's one of the few languages that does, and it's not really fully utilized. But this gives us basically direct manipulation of any addressable value in any of the components, regardless of the type, and get a nice user interface for it. But really, kind of the coolest part, I hope this is mine, is this, I haven't even showed it to you yet. It's this sort of it's this object model where so far we've been talking about these components, but we put them all on a single object in this hierarchy. So this is a default, object, but we could have multiple objects. Well, first, an object contains components and doesn't really do anything else. It has a name and it can have subcomponents. Does anybody work with Unity or have worked with Unity? So this is familiar, right? Yeah. You can have, objects can have sub-objects, which can have components or not, or other objects, and that's basically the whole thing. Most of the data model comes from the components you put on it, which makes it a very sort of almost programmable tree structure, which is already very versatile. So we can get a lot of mileage out of this while getting all of these other benefits of interactivity and UIs and stuff. To help you imagine this primitive with a body of component libraries and systems, I'll show you some that I threw together really quick. One for doing UI stuff, quick and dirty UI. Yeah, that's all I'll say. So this project has a bunch of stuff that's already in it that is going to serve a web page that will show our layout. It also gave us this sort of, you can do anything you do there, you can do in code as well in a pretty declarative way. But it gave us this sort of starter layout. There's this text node with quick text component, layout with a quick layout. If we activate this, we get hello world, which was the text on the text field of the quick text. Obviously, changes it updates in real time. Whoa, big deal. But we can also add other objects that have these components that would just update the UI. So I created an object with a quick input component and called it name. And here I'm creating an empty object with no components, using it as a container for other objects, these button objects. And our layout system uses that structure of that container to go from a column layout to a row layout. And so we didn't have to do anything, it's just the convention. So getting stuff out of the structure that we have here. And it did something, so that's because we have this event handler. We can view the source, and this is inspired by PySimple GUI. This model. It's kind of like an Elm thing, but we're going to log what the event was and the fields that were set, put it in a field on this struct, and then we're going to do some stuff. This is all, again, like contrived example code, but we get the quick text component and set text on it. If we look at any of these quick, component UI components, there's no rendering stuff here. It's just data. That lets us have the renderer be totally separate, and we could render it in a totally different way, like in the terminal. And we would just get that for free, and it works, does exactly the same thing. And then because we have this terminal UI, we could very easily make this an SSH server. Since we have an implementation of a SSH handler, we can just put this SSH server component on the root, and we don't even have to do anything. We can just hit activate, and everything wires up. And so now, besides the UI, we have this SSH version of the UI, which updates everything. And live, we can change the hierarchy. We change the reset button to a quit button, which has a default handler that will quit. Here's another one, totally different. File systems. We'll make a virtual file system in the same project. We'll put it under like an empty object called FS. We'll make a couple files, an object with a file buffer. So this is a struct with a slice of bytes. It's just bytes in memory. Empty directory can be a empty object can be a directory. Put another one in here, file2, and we can extend the host environment, in this case VS Code, to have custom editors for whatever the object is, depending on its types or components or whatever. And then we can do a custom dynamic file. We'll call it cool file, which has this cool file component, which here's the interface to do a slurp-based API for files, read file, really easy. And then it's going to do the file name and the Unix time. And so this container that we put up here, put a treefs object on it that converts this whole subtree into a virtual file system. And then we could do a lot of things, but we'll just make a fuse mount with that file system. And then there's a lot of things that we can do with this. And now when we go, we can start playing with this file system that we made, of course, as dynamic stuff. But you notice I did it in the same project because we could also navigate over to this layout hierarchy. And it's just kind of cool that you can see this layout as a file system. It doesn't do anything. This scrubber's in the way. Can I move that? Apples? Nope, can't click. It's OK, I know how to get back now. So did I do the thing? OK. So I put a component on that name object that I made called field file. Again, another contrived thing, but it just goes up to the event handler that has all the submitted data and returns that, so that ultimately we can set the data and then get the name. There's a name line there. You can see. Let's see if we can get that scrubber to go away. This was supposed to save time. All right, last 3D scene. It looks like Unity. Hey, because it's basically the same thing. A lot of design tools are basically a hierarchy and an inspector with custom editor views, and we basically have that in VS Code now, but it could be for anything. So the idea is to make a kind of a Unity for all software, and then you have something that feels like a design tool, especially for software system integrators like me. And this is how I intend to throw together software very quickly. Anyway, that is all I have time for. Also, thanks to my sponsors, GitHub sponsors, I'm starting to do consulting again and looking for collaborators to build stuff with this, tools, environments, experiments, whatever. But let me know what you think of this. I have no idea what anybody would think of this if they saw it, so come tell me. That's it.